Periodic table development. What we recognize today as elements were not always considered so. However, some of them were known from ancient times. Most of these 9 have symbols that do not correspond to their names in English, but do match the name in Latin. Most of these elements are ones that are found in their pure form in nature, or are relatively easy to separate from their ores. Other elements were discovered in the medieval and Renaissance periods, bringing the total to 15 by the middle of the 1700s, when modern chemistry was really begun. By around the time that Dalton proposed the modern atomic theory, that number was swollen to around 40 elements. Scientists began to search for some unifying and organizing principle to bring order to this jumble of elements. By the late 1820s, 53 elements were known, and Johann Dobereiner had noticed some interesting relationships among the elements that had similar properties. In 1929, Johann Dobereiner published a paper showing a regularity in the molar masses of elements with similar properties. When one looked at the relative masses of groups of 3 elements with similar properties, the middle one seemed to be close to the average of the other 2. While interesting and perhaps useful in finding other elements, it was not very helpful in organizing the elements. By the mid-1860s, more elements were known, and organizing was ready to begin. In 1863, John Newlands published a paper that suggested that the elements were arranged in octaves, by analogy with music. The 8th element in order of mass had similar properties to the first. This pattern, however, broke down after relatively few elements, and in part because of this, Newland's work was rejected. 2 other scientists, however, were also working on organizing the elements. A Russian scientist named Dmitry Mendeleev and a German scientist named Lothar Meyer independently reached nearly the same idea about organizing the elements according to the properties they exhibited. Both published their work in 1869. Mendeleev got credit for the work for 2 reasons. First, and probably most important, he published his work first. The second reason, however, was more significant. Mendeleev proposed the periodic law as an organizing principle. As he originally stated it, Mendeleev's periodic law said, when the elements are arranged in order of increasing atomic mass, there is an evident periodicity of properties. This allowed him to say that there were elements that had not yet been discovered, and to predict their properties. He did this with 3 particular elements, known today as scandium, gallium, and germanium. These elements were discovered within 15 years and had properties so close to those predicted by Mendeleev that it gave other scientists great confidence in his foundational idea. Mendeleev's periodic table does not look anything like the modern version of the table. This is due to the specific data that Mendeleev used to do his organizing, which was the formulas of the highest oxides of the elements. This led him to place elements in the same group that had remarkably different properties otherwise. As a result, he split his groups into A and B subgroups so that the similarity in properties could also be maintained. The modern form of the periodic table is organized on a different principle, discovered in the early 1900s. This principle is the electron configurations of the elements, which the current periodic table was designed to represent. The modern form of the periodic law says there is a periodic repetition of chemical and physical properties of the elements when they are arranged by increasing atomic number. It deals with atomic number rather than atomic mass, which was not discovered until well after Mendeleev's time.